Hello, and welcome to TopSolid 7. You know, sometimes designs get to be extremely difficult and challenging. Let's take the example of a timing screw. For example, let's say that you have this bottle. As you can see by all the faces on here, this bottle was clearly scanned, so it's reverse engineered. Now, the goal here is we want to take and create two screws or augers that will move this bottle down my conveyor and twist it along the way as well. That can be really hard to figure out. Well, thanks to the brilliance behind the development team in our special service department, even working with geometry like this can be relatively simple. How does it start? Well, it starts by describing what we call a scenario file. And the scenario file is pretty simple to understand. Basically, you're describing the location of the part per screw at an exact moment in time. And then the software automatically will create sections of that part at each of those locations, and then it will generate for you the timing screw. Let's see how it all works. So here we have everything already assembled and ready to go, and we're going to apply the special timing screw function. So here I'm going to go to create a new timing screw. The software is going to ask me for the frame that the screw is based off of, or the part, pardon me. Then it's going to ask me what the part is. That's our part. Now we want to use a scenario, and we're going to apply this scenario to this as the master screw, and we're going to use this scenario. Now we're going to keep it simple to start with, but we're going to use both screws. Tell this one to go counterclockwise, and we'll tell it to trim the roughs. You can see there's a second scenario in here. That's if I want to run multiple parts down the screw at once. I'm going to go ahead and hit validate, and now TopSolid is going to do all the heavy lifting for us. Now if you think about it, most companies out there, if you have to design timing screws like this, are going to spend hours, if not days, trying to create a screw to move this 3D scanned object down the conveyor. Thanks to a little thought process and a lot of hard work, again, like I said, from our special service department, hours or days of work can be literally turned into minutes of work. Here at this point, if you look, there's a status bar at the bottom. Here it's creating the sections automatically right now. Once it creates the sections, it will then use those sections to generate the surface automatically. And then, using the power of TopSolid, it will trim the two roller bars by that surface, making our timing screw. It's almost done. Now it's smoothing the sections, creating the surface, and trimming the model. Voila. So here you see an automatically generated timing screw. And that's pretty cool, but it doesn't stop there. For example, I want to test this because I want to make sure it's doing exactly what I intended it to do. So I'm going to put ourselves back into a plan view so we can look straight at it. And I'm going to speed this up to about 20, and I'm going to hit play. And that's right, you get to watch the animation of the timing screw. So it's coming down the conveyor, and now watch what happens to this part. You can see how the screw is pushing the part so that it turns it. Let's speed this up a little bit, slow her down, why not? It's going through the system. Now it's speeding it up. You can see in the screw, it's speeding it up to space the part at an exact distance. Pretty cool. Next, let's see how to machine the screw. Okay, so now that we've designed our screw, now it's time to machine it. Now, just to win time in this video, I've prepared the machine already. In other words, I picked my machine, I loaded my fixtures, I loaded my fourth axis, I've loaded my part with the stock model as you can see, and we're ready to machine. Now, because it's TopSolid, we always have a good strategy and a good way to machine specific types of parts, because we take the time to really analyze the requirement of machining a part like this. So here in our 4 and 5 axis menu, we have a function here called screw milling, and it's specifically made for machining parts like this. How does it work? Well, let's start by just grabbing a tool. Here I'm going to start with a little 1/2-inch end mill, and I'm going to go ahead and select some geometry. Now the geometry I'm going to select are either the edges or profiles, doesn't really matter. I'm going to choose the profiles. Go to here, choose this profile here, And now the software is going to create some sections between those profiles automatically for us. Perfect. From here, what I want to do is I want to decide what kind of computing tolerance and stock to leave I want. I'm going to leave 20 thousandths. Why not? Maybe we'll do an 1/8 inch depth of cut there, and maybe I'll step over here will be, let's go 0.2. That works. Oops. Those darn double decimals. There we go. Good enough. If I go to strategy now, you can see you can control the direction of the axis, the direction of the rotary, and whether you're climb cutting one way or zigzagging. Now, we also have one really awesome feature. Besides the fact that this is going to rough this in 4-axis continuous, it's also giving us the ability to switch sides that we're cutting on. I'm going to show you what I mean. If I leave it here under normal displacement, let's just go ahead and validate. The software is now going to crunch out the toolpath. It'll calculate it, and in a few short seconds here, we will have the roughing toolpath. Okay? Let's turn on the full machine sim because it's just more fun this way. And now what you'll see, let me rotate this a little bit, is you'll see this tool come down and it's going to plunge in and do its cut, right? And you can see we're on the left side of the thread right now. Now I'm going to let the simulation go. And here, it machines exactly to where it needs to. And then it comes back, but I'm still on the left side of the thread. Now, in all reality, what I'd like to do is I would like to go climb cutting down one side there on the left side and come back down on the right side. So let's try that. I'm going to go here. I'm going to make one simple change. Under strategy, we're going to go to alternated displacement. And now what this is going to do, it's going to be again the same 4-axis continuous roughing toolpath, but I'm going to climb cut down one side, flip over to the other side, and come back along the other side of the tooth. Let's have a look. So here, again, we're cutting down the middle, actually in the middle in this case. And then we're going to flip-flop back and forth. Perfect. Right down there. Now, this is roughing. Let's have a quick look at the simulation of this with material removal. So here what we can do is go into Verify. And we're going to go ahead and check the material removal. So I can hit play there. And here you can see it's animating it. I can speed this up, slow it down, whatever. But you can see, if we zoom up on it, it's doing a great job. Maybe what we want to do is just see the results, so we'll let this run in turbo mode. And there's your result. So you can see the screw is nicely roughed out. Perfect. Now, how about finishing? How do we finish the screw? Well, again, same function, in fact. We just switched to finishing. Watch. I'm just going to use standard copy and paste. Pardon me. Copy and paste. And I'm going to go edit this, and I'm going to change the machining method. Right up here at the top where we have kind of machining, I'm going to double click. I'm going to switch to finishing. And all I'm going to do is switch to my ball nose cutter. And in this case, and you can see the type of cutter I'm using, in this case what I'm going to do, I want to be radial for sure. Also, so you know, you can go longitudinal, so I could tick-tock back and forth between this if I really wanted to, but I like radial. I'm going to set my scallop height at, I don't know, let's go to maybe 5 thousandths. Good enough. Go to right to 0 there. I'll leave the tolerance at 2,000 for now. It's good enough for me. And I am definitely going to do this alternated back and forth, but I'm also going to show you something else you can do. I can offset the center value, and what that means is, for example, I can say 1 inch. As opposed to my tool staying right at Y0, now I'm going to be at 1 inch to one side versus the other side. So we'll let that crunch out now. And we're done. And now you can see the finishing toolpath. Looks pretty nice. Let's watch the simulation, see what it does. So here I'm going to watch the simulation. You're going to see that we come down on one side, and you see how the tool is off to the side there? Perfect. Now watch what happens when we come back on this side. Once we get down there, I'm going to slow down a little bit so you see it. Now what will happen is we're going to offset back to the other side, and notice we're cutting back on the other tooth, or the other side of the tooth, with the tool now on the front side of the part. So not wasting any motion going back or forth. This is just another great example of TopSolid going to the highest level possible to provide the proper solution for machining parts like this, as well as the design of these parts. If you think about it, we designed this part ridiculously fast. and we're able to program it equally as fast. Thanks for watching. Hope you enjoyed what you saw.